here, and then we mix it with sensitized sheep red blood cells. So the sheep red blood cells we just get from the local abattoir, because once they slaughter they just pour the blood down. So this one we collect, and then we bring it into the lab here, and then we add the surface antibody onto it so that it can bind. Then if the patient's serum contains the surface antigen, agglutination will happen, and down here, because it is U-shaped, it will collect. If it is flat like ELISA, it will just spread, so it's difficult to know whether positive or negative. Then, of course, we have a diluent for it. So this is a diluent. This one is empty. We prepare the diluent here, and also positive control. We need a positive control, so we also make it here. This is made from high titer. Maybe we collect from the blood bank somewhere. Then these are just the negative controls, so normal syrup. So this entire kit, what we buy are the plastics and the tubes and the paper. The rest of the things we make it here. So we were supporting the regional blood banks, as well as the big referral hospitals, as well as ANC clinics that have very high numbers. As you know, even with rapid tests, if you have 100 samples to run, those are 100 rapid tests. So it's quite tiresome. But if you have fewer samples, again, this will not work. So you have to strike the balance. Then also the other advantage is, since the centralized production means we can control for a good kit and also reliable results. In case there's a problem, we can go and retrain, or we can go and support these facilities. Okay? So this was the first one.
What can't go for serum
volume. 100 microliter.
100 microliter.
Yes. And this is good for screening 200 tests. Of the serum? No, 100 to 100. Unless it is highly stained, that's when we do a 1-to-1 using the labels. Then we moved to the lateral immunochromatographic test kits. These are for different tests, including hepatitis. So it's the normal rapid test. So this is a hep cell, hepatitis B surface antigen rapid test kit. Normally, just like you would do for this. Now this is for the small quantities. In terms of reliability, this one is more stronger than this, but this one is easy to use. So even small clinic, they can use. Okay? Now the only challenge with most of these tests you find in our continent, our systems are a bit rigid, because you have to have what they call WHO pre-qualification. And this is the biggest challenge with African products. Even when own countries can produce their own test kits, they have to be WHO pre-qualified. And one of the challenges with WHO pre-qualification is the funding level for you to be pre-qualified, the amount of investment most African governments take time to invest in this. However, with the movement of various African countries from lower income countries to mid-level and higher level, it will force those countries now to have in-house health products that are now not donor-driven. Okay? So that's one of the challenges, even as you invest in production. Then the other product that is common in Africa, and one of the advantages of this is the 30 minutes result of this. And also, expense is quite low. And since it is in-house produced, then the volumes can be built depending on the need. Because one of the challenges we have in many African countries is that the disease hits us when we start the procurement. Then it takes time. The disease finishes as we are still procuring. So at least when we have in-country production, then at least we will save lives and we will be able to respond.
What about the specificity?
It's quite specific because one of the advantages of this particular test is that, as I told you, most of these products are generated from research that has been done here. So what that means is that the strains of parasites are local strains. So at least if it's a local strain, their specificity is quite high, as opposed to a universal strain, which maybe covers South America and the kind of malaria that we have. It's a different story. Is that we are producing what we call culture media. I'm sure you are working in the microbiology lab. I did not put some petri dishes in. Culture media, as you know, has a challenge of water quality. Many of our labs use either spring water, borehole water, rainwater. So to make the microbiology lab standardized is a bit of a challenge. So most of the time, preparation of media is a challenge. So one of the things that we've done is we are helping the hospitals by producing for them the different medias. Blood agar, which are Makonki, SLD, charcoal, yes. But all on demand. So the idea is we have a marketing department, so they will receive the order, then they will give that order to the production manager, and that production manager will instruct the microbiology section to produce depending on customer need. So the beauty about this also is that if you want a certain variation of salts, it is possible. So at least both specialized media and universal medias, we can produce in-house. The only challenge with culture media, as you know, is cold storage. So the cold chain. Here in Nairobi, we don't have a big challenge, but many of the labs, as you saw when we were in the field, don't have very good cold chain system. If we are to take this sample to Impala, you can already see we need to have a refrigerated system if it's the car, and also on site we need somebody waiting to receive so that they can put it in the refrigerator. You saw in Impala there is no electricity, right? So you have to imagine how to control for this and where to position your microbiology labs. So those kinds of challenges arise as well, even as you make this. But this is one thing I'm sure even in your countries you can be able to do it in a centralized area and dispatch to the smaller laboratories. Okay? But in terms of operations, it is quite cheap because you will not be there throughout to prepare media. So you want a situation where one, it is standardized because between you and her there will be variation. But if it's centralized, we control for those challenges. Okay? But once I will ask for that. This one I'm sure you know about it, the virus transport media. I don't know, did you produce some in your place during COVID? Nothing.
Nothing. No.
No.
Transport measure.
No. VTM.
VTM.
No.
No.
We produce for collection in the field. See, Ethiopia.
Collaborated with Ahari.
Yeah. Right. So it's one of the commodities that was a bit of a challenge. In Africa, we realized that we were on our own. When we needed test kits, they were not available. When we needed commodities, they were not available. So one of the things that KEMRI did in response to COVID is to quickly repurpose our microbiology lab to produce this. And I think we produced over 2 million of this and dispatched to different places for collection. And the samples now could be taken to different labs. They didn't have to come back to us. So that is also the beauty of government, because once it is produced in a central place, it is distributed and it is possible for them to use it in different places. We have this product, which we're calling KEMRI. This is a PCR tester for COVID, and it is also in response to unavailability of test kits. So when we realized that we could not buy from the international market, we started to manufacture
Produce this.
for our domestic use, because as I said, WHO pre-qualification. So in as much as we know that the quality is good, it's difficult to break into the international market if you don't have that WHO qualification.
So you are allowed to use it even after that WHO qualification as Kenya.
That is a country decision. As a country, will you watch your people suffer or will you do something? So you have to respond in some way.
Okay.
It might not be the ideal way, but
What do you may have?
it's working with what you have, because at that time we were desperate. Everybody was desperate. We can't receive test kits. We can't see, as we are not sure whether, especially the people that were in isolation. It was a tough time, because you're keeping somebody in isolation and you cannot tell them whether they are free now to go back to their family or continue being in isolation. So this,
But normally in our country, they just supply the villagers themselves. They don't do it here?
they support, but not fully.
Not for them.
That's why you're receiving entire supply, so that for us, we are considered, we can stand on our 2 feet.
Ah, yeah.
Yeah.
Meaning there are some qualifications that you meet and
Yes.
they can agree that we cannot.
Yes, for us, they say, I think you have resources
Yeah,
to
yeah, yeah.
support.
So which department manufactures the PCR kits?
Innovation.
All production is done here.
Innovation department,
I'm
right?
showing you products of this department. So what KEMRI has done is the different units. I tell you, there's a center for respiratory disease, there's a center for virus research, there's a center for microbiology. The scientists now come up with the product. Then we incubate it here, because it's a 13-step process before you arrive at a test kit. Many will fail. About 80% of them fail. They don't get to production level. But the beauty about it is, since we are centralized, the staff here are dedicated for production. So they are not normal scientists that you will see them in the field collecting samples or this kind of thing. So their work, when they come through this door, is to think about today which kit are we producing, and they work on that. Okay. Then this is work that we did with the Japanese as well. This is Immunoline. We call it Rift Valley Fever Human IgM Antibody Detection Kit. It's also an RDT, a rapid test. but we also have an ELISA platform as well for it. And the beauty about it is that we were responding to a Rift Valley fever outbreak, but also at the same time, using the same platform, we can be able to make different other test kits. So it's the same kind of pipeline we are using. And the other advantage about it is that very few countries in the world are producing this. One, because it's not a disease that is common to all countries. I don't think there is Rift Valley in your country, and also in your country. But you see, it's a huge problem for us in countries that have the Rift Valley, as it is called. So many donors of pharma are not interested in producing such kinds of tests because they are not like HIV or hepatitis where there is a lot of market. But as a country, we have to respond. Then the other advantage is that the veterinary side. So sometimes you make a test kit, you think you're making it for the humans, but the biggest market happens to the vet. Because as you know, Rift Valley fever is a zoonotic disease. So in most times it will start from the animals before it crosses over to humans. And the first casualties are normally the veterinarians and the animal handlers or the slaughter people. So most of the time it is self-limiting, but at times it becomes fatal. So sometimes we have to produce where nobody is producing.
That's nice.
Recently we are looking for an ELISA kit for Rift Valley fever. I think we only got Panadea.
Yes. It's quite tough, right? Yeah. And it's really expensive.
Yeah, very expensive. I think about 6 million per kit.
Yes. So at least, but that is Uganda shillings. It's not US dollar. But yeah, so
but now I see this is human, so
yeah,
I'm talking about
we
veterinary, so is it?
we can be able now. What we do is we switch the catching antibody from anti-human to
animals.
Animal, anti-rat, anti-goat, anti-sheep, anti-camel. This approach is what we work with. Okay. Then as it is born from TB work, so it's a disinfectant. It's a hypochlorite based sodium hypochlorite with a very high pH 12 to 13, and what we are doing is, as researchers, we develop the product, and then since we don't have bulky machines, as you can see, it's quite bulky, 5 liter. We can even produce 20 liter. What we're doing is we now partner with the private companies out there. So we send our staff to supervise, and then we do something we call a framework contract, where we have the national medical stores ordering from KEMRI. Then KEMRI subcontracting the private companies so that we grow the public-private partnership. You understand? So at least we are assured of the quality, and again, we are not stuck up with just producing bulks and tons of herbicide, because in a year we are looking at 60,000 of this at the very lower side. COVID time, I think we did over 150,000 of 5 liters. So you can see it's quite something. You need a big factory to
produce.
support. Yes. Then which one is this? This is side in another form. Then we have the hand sanitizers now. Also those we make the formula here, and then we again subcontract the private farm to support them as well, so that they can help us in the production. In here, we protect the product, not here. So in every, when you think about production, you have to think about you not hepatitis preparation room here, manufacturing room here, herbicide preparation room here, and finally dispensing and out. Or if not out, material goes back here, comes back to dispatch area here. If it's small material, it's dispatched. You understand? And we have packaging over here, labeling over here, and QC. Never forget QC. And QC should be far from production area. The people working in QC, as you can see, they never meet. This is their point of departure. QC people go this way, production people go that way. So every time when you have an idea about making a production facility, think that way.
Dr. Alan, why?
Well, Barry, to tell you not to enter. Then we have a place to put our material. But today we will carry our stuff because temperature is about, in some room 25, some room 22. When there is a problem, red means good here, but or yellow means very bad.
Oh.
It's the other way around here. So if there is a big problem, you just stop the power. It cuts out entire facility. Okay? If there is a challenge, you can reset. If you come and just find that there is some problem, you can reset. 55?
55?
65.
Okay.
But alarm will come when it is
55.
55. Room temperature 25.
Then 26. Indeed.
It can
25.
fluctuate. Okay? Temperature is about, in some room 25, some room 22. When there is a problem, red means good here, but or yellow means very bad.
Oh.
It's the other way around here. So if there is a big problem, you just stop the power. It cuts out entire facility. Okay? If there is a challenge, you can reset. If you come and just find that there is some problem, you can reset.
And in case I don't say the division is here, this is minus 22, this is 4 to 8. And then this way the division is done. This is 37, and then 5, it's usually 36.
So you do both bacteria and virus surfaces?
Yes. This is the normally it's got the green benches here and there. Yes. Then the smell and the temples over the two. After we dry, then even the salinity is being tested from this side. We use the water one so that in the morning we can in case of any contamination, we can get from the blood. It's usually stored in this place. These 2 to 8. The alarm, it usually chooses the error, but it will read the limit, but once it's off, it's still. We have different types of media.
Samaran dextrose,
Agraria.
Mm-hmm.
for fungi? This is Molamento.
Macon is there. It's like in front of store, but we have excelled it. So we have got the plated and the tubed. Yes. But the tube now we don't have metal because they go after the customer's request. This one.
For coding, huh?
The coding machine. This is the solvent we usually use.
For
Coding
dead.
machine, which shows the batch number, the manufacturing, and the expiry dates on the plate.
And production up to
It's
50 per
indicated.
hour.
This is the information we feed here. If the sheep blood, we have the plate here. Then someone has set. Then you start. When you start, you wait till it shows print ready for printing. Then you start. You can put even 3 to 4 plates. Then someone is there to pick. Yes. You can feel and the same ones that are used. It usually comes with the where you sourced the machine. You can't buy from any other person.
Linux.
Because this is Linux. This is Linux.
They should be together.
So yes. If you don't want so many maintenance issues. Yes. Put your plates here. Like that.
So this is the one that does that.
Sorry?
So this is the one that.
Yes. Yeah, this is the one that controls now the movement of the.
They normally do their cell cultures here, whereby they have the microscopes, the biosafety, and the incubator which is supplied with CO2. So at the moment, the guy was here, he was doing the toxicity levels of a specific extract towards the pancreatic cancer cells, but unfortunately he has left. He has some other things to do. So for me, I'm doing a different thing. I'm testing the toxicity of the crude papain enzyme against the skin cells, the epithelial cells. But at the moment, I'm doing the extraction, so I've not yet proceeded. Yeah. So this is the isolation room. We normally do the centrifuge. The cancer cells tube is normally use this lab because it's specifically for that, because they can't contaminate all other. With your protocol for mine, it's for 10,000. The rotary RPM. For 20 minutes at 4 degrees. So when you set it, it depends on the rotor you're using. The rotor normally has the ID, which is specifically for the rotating tubes, like those ones is the same. So for mine, so first you're supposed to balance the extract, for example, like this. When you put it in those tubes over there, I can't touch them because I've not cleaned them. You have to balance them with a way balance like this, but it's a bigger one. So the volume must be balanced so that you can put it over here. So when you put it over here, you're supposed to balance. You know the balancing of the rotors. When you balance them, you have to close it with there's a closing something which is used here. You're supposed to close this tight so that when it's spinning, it's not supposed to explode. So that's normally what we're doing here. Then you insert the rotor within here. This can be G8, yes, the speed, G8. Then the speed we are recommended to use, the time, and the temperature. So basically that's all about this place. Maybe you can yeah, it's this. The ability of the cells in the tubes. You know the flask where we normally see the cells? It's a carbonated flask, I don't have one here. And then the other one over there, when you're preparing the diagnostic kit. You've ever seen a diagnostic kit? You normally have the conjugate pad, the sample pad. So these are going to us where we're supposed to operate that machine over there.
This one, huh?
Yeah.
It's called?
This one over here. This machine is used to spray the sample pad, the conjugate pad.
Spraying machine.
Yeah, it's a spraying machine. Yeah.
You spray for what reason?
For the diagnostic kits, test kits.
Why do you spray them?
Because you're supposed to induce, I can't recall exactly, but you know that pad, there's this pad, whereby you can't do it manually. The machine has to do it. So it's normally controlled whereby it can spray it, you have to clean them and spray it. Yeah. I've never done it, so it was just. This one is a lyophilizer, but it's not working.
Is it?
Lyophilizer. It's a drying machine.
It's not working.
But it's not working at the moment. Lyophilizer. Yeah, lyophilizer, yeah. So what is it about this lab?
Not functional.
At the moment is not. Then it's breaks, yeah.
This is
Homogeneous.
homogeneous. Huh?
Immunological cell. It breaks.
And this is autoclave, huh?
Many autoclaves.
Manual.
No. Only the show. It's I wash. If something has plastic.
55,
55?
65.
Okay.
But alarm will come when it is
55.
55. Room temperature 25.
Then 26. Indeed. 25.
Fluctuates. Okay.